Okay, let's look at a typical AP question of the day. This has really nothing to do with the chain rule, but it's a question that we need to bring up. So it's calculator inactive. Can't use your calculator because your calculator will just compute derivatives for you. So take a second, think about it. Remember absolute value functions. The key is always to write it as a piecewise. So pause it, see if you can figure out the answer, and then come back for my explanation. So as I was saying, absolute value, always can write them as a piecewise function. So remember, for the left side, we change the signs. And for the right side, we keep everything the same. So this is when x is less than what? Where's the changing point? 3. And this is when x is greater than or equal to 3. So it's asking us the derivative at 1. So here's the function. So the derivative of our function here, if we take the derivative of these pieces, for the first part, it's -1. For the second part, it's +1, which makes sense because think about our absolute value functions. Okay, absolute value function, this one is at 3. Okay, the left side of it has a slope. It's a line. It has a slope of -1. The right side is a line. It has a slope of +1. As long as there's, nothing else in front of this x, that changes the slope. But in this case, it's just -1 and +1. So at 1, x is less than 3. At 1, the slope is -1. All right. So let's use the chain rule with trig functions. Chain rule with trig functions. Now, here is what will hopefully help you with the chain rule with trig functions. ETA. Okay, exponents. Now, let me clarify that on the trig function. Okay, on the trig function, because we're getting ready to look at one where the exponent is not what we deal with first. Okay, on the trig function. And then you deal with the trig, then you deal with the angle. So let's look at this one right here. Sine of 2x to the 5th. So when it talks about exponents, it's talking about the exponent right here. Okay, so this one, sine, is raised to the first power. So we really don't have to worry about that exponent because, to the first power, there's no derivative to be taken there. Okay, so we skip that one on this one. And then we deal with the trig. So the derivative of sine is cosine. We're doing the chain rule, so remember that inside doesn't change yet, times, after the trig comes the derivative of the angle. So the derivative of 2x to the 5th is 10x to the 4th. We don't leave it like that. We move that 10x to the 4th in front of the trig function. And guess what? We never change what's inside this trig function. That angle cannot change using our derivative rules. Okay, let's modify it slightly. Okay, we've got sine of 2x to the 5th. So that 5th power is still not on the trig function. Okay, if it's on the trig function, it's going to be between the trig function and the angle. If it's right here, then that's just being applied to that 2x. So h prime of x here is the derivative of sine is still cosine. We don't touch the angle, times the derivative of the angle. So this time, that derivative requires the chain rule as well. So bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside. So to make this one look a little bit better, okay, the 5 times the 2 is 10. 2x to the 4th, we can't multiply the 10 and the 2 because the 2 is being raised to the 4th. Okay, so leave it like that. And then cosine 2x to the 5th. These cannot be factored out. Okay, don't look at it that way. This one is inside the trig function. Trig functions mean nothing without an angle with them. So if they don't have something that follows them, it doesn't mean anything. So you can't move that. That doesn't change. Now, finally, see how this exponent has progressed. Now the exponent is finally on the trig function. So we deal with that first. G prime of x here will be bring down the 5, subtract 1 from the exponent, keeping everything else the same, times, after the exponents comes the trig. So cosine of, you keep the 2x the same, times the derivative of the angle with 2. So then we can multiply the 5 and the 2 and get 10. Sine to the fourth of 2x, cosine of 2x. Now, sometimes they do it in order of like sine, cosine, tangent. Sometimes they'll put the cosine first because they increase the exponents. It doesn't matter which one comes first, as long as you have them both there. The sine is raised to the fourth, the cosine doesn't have an exponent. Okay, so notice how similar these functions are, but how different their derivatives are just because of the placement of their exponent. Okay, it makes the derivatives very, very different just because of that exponent moving. All right, so let's look at a few more. Let's recall some of those other trig rules we don't use as frequently. Okay, again, there's a power of 1, but we don't have to worry about that. So we skip to the trig. The derivative of cosecant, remember all our cos are negative, and cosecant is the cosecant of the angle times the cotangent of the angle, and then times the derivative of the angle. Well, in this case, it's just 1. So really, this is all we're looking at with our derivative there. Okay. All right, let's look at this one. -4 tangent of 3x. So dy over dx is equal to that -4. It stays. Okay, it's a constant multiple. Tangent doesn't have an exponent. Okay, well, it has an exponent of 1. So we just take the derivative of tangent, which is secant squared, keep the angle the same, times the derivative of the angle, which is 3. I don't really like that there aren't parentheses around the 3x there, but they're kind of supposed to be. So then we can multiply the 4 and the 3 here to get -12 secant squared of 3x. They love the chain rule with trig functions. They really do. I'm just being honest with you, letting you know. You got to have these down cold. All right, exponent of 3, we deal with that first. So nothing else changes. We're just taking the power rule with that exponent. So we brought down the 3, everything else stayed the same, and we subtracted 1 from the exponent to get sine squared. Times, the trig function was sine, so the derivative of sine is cosine. Keep the angle the same, times, now we're finally at the angle. The derivative of the angle is 8t minus 3. So let's make this look a little bit better. Not a whole lot we can do, but we do need to bring that 8t minus 3 from the end. We need to bring that forward. And I'm going to leave it. I prefer sine to come before cosine. Like I said, I don't know which one they're going to do. So just recognize that it doesn't matter what order it's in, just so the sine is squared, the cosine doesn't have an exponent. Okay, so practice the trig rule with, the chain rule with trig functions, 47 through 50.